All right, good morning. So, I fetched some tea. That will help me get through the morning. So, very warm welcome to all of you. And yeah, so today I want to check out a few new things to implement. Let's see what we got here. So from the latest stream, I opened up a GitHub repository. So it's basically just named HyperWorks tools for now being. And yeah, I uploaded the initial code here, and you can check that out. I then created a bunch of issues, which I think would be worth looking into. And yeah, so the issue we will be looking into today would be to implement the RBE3 elements as well. Because I think that's rather straightforward. And yeah, after that, maybe the 3D elements as well. We will see how it goes. So it's always not so easy, I would say, to just implement the right thing or the how to choose the next thing to implement, because whenever I have something like this, my mind is completely racing, and yeah, I'm getting ahead of myself on which one to take first and implement. But yeah, so I think the RB3 one is rather easy, hopefully. Let's see about that. All right, so I think also the camera should be working. Yeah. Now you can see me too. All right. Yeah, so let's start implementing this. So what I did was create a branch for this and checked out this branch here. Wait a second, my OBS is giving me flashes. Not sure why. Yeah, hopefully it's all good. Yeah. Turn down the music a bit. Okay. All right. Now, for this thing to work, I also put the models here. Yeah, I'm not sure if this is really necessary, but yeah. I will open now the simple rigid one. Simple rigid one in HyperMesh. I think this is not the correct one. Something like this. All right. Now, yeah, I think the image quality is not that good, so I think I will just leave the camera off. Yeah. I think that's better. Now, okay. Now let's save that with a different name. Save as HyperMesh model. So rigid is not correct anymore, so those would be plate simple RBE3. And normally what you can do is change the config here, but I'm not sure how to do this here. So is there a config change? Change element config. Yeah, could be that this is working. So change config to 1D RBE3. Yes, I think that's all there is, right? I think there's also an option to show the names of the elements to make it sure that we have a RBE. Well, can you read this? RBE. Well, you should definitely also see it here. Should you? No. That's components. Let's make it elements. Double click here. RBE3. So this worked. I just remembered that this didn't work in the previous versions. So when you wanted to change RB2 to RB3, it changed also the connectivity. But somehow I think there's a macro now ensuring that the connectivity is the same thing. Okay, now this is working. Let's see if it's working. So this is the same model with just one connector. And let's maybe just run this. So analyze here, then let's I think that's the correct folder. So let's create a run one RBE3 folder. Yeah, this is correct. Save that, export that, and run it. So what is changing now? It will be the way of getting the nodes from the RBE element. Because if you remember last time, we had something like an RBE2 keyword. So if I just go here to our standard R run 1, in the FEM file, there was all the grid values. So those are the nodes. And then it started to having, oh wow. It's just, okay. We can have a component information here. That's good. That's also something to implement. Yeah, but I'm getting ahead of myself. So the RB2 element here is this one. And I suspect that RBE3 will be different. So let's see how the RBE3 behaves. So that would be this one. And let's also go to the RBE elements here. Okay. Yeah. You got to love it, right? Okay, so I see already a problem here. So it cannot really differentiate between 1, 2, 3, 4, 5, 6, which is the DOF, and then there's 1.0. Man, fun times ahead. Fun times ahead. Okay, so we have RBE3 here, then this is for sure the element ID, and then this is the reference node. I don't know why it skipped a cell here. Why this is. Let's maybe check that in the documentation. So if I just don't mind me searching RBE3 OptiStruct. If we search that and see what the card image looks like, so this means that how you would have your fields. So you have the keyword RBE3, then the element ID, and then this is blank. I'm not sure why, but maybe spaces, I'm not sure. So then you have the reference grid. So this would be the main node, I think, right? And then you have the reference C. This is a coordinate system. Ref C, global components of motion. Ah, no, this is the DOF. This is the DOF, yeah. Then you have the weights. Then you have something like C1, whatever that is. Global components of motions that have weighting factors. So 1, 2, 3 has the weight factor of 1. What is GIJ? Grid point whose component have weighting factors and average equations. Yeah, so those are the nodes then, right? So I think 1, 3, 5. Then there's a 4.7. Oh, those are weights now. Okay. So you have C1, 1, 2, 1, 3. Then you have a weight. Then you have C2, whatever that was. What is C? Global components of motion that have weighting factors. Yeah, so this has to be differently preprocessed. So yeah, as always, there's a quick and dirty solution. You could just scan through all the values, and whenever you have a dot in there, you can just leave it away. But I don't think this is very good. So we're interested in all the G values, etc. Do we know how many there are? Huh. Let's see, how does it look like in our code? We have now here the dov, then we have the await, then we have another dov, and then we have nodes. So actually, it's not that kind of straightforward to me. So this here means that I have to change the way I read that in, because this would be in the current approach where space is getting replaced um, with characters where to separate. This would not work. I clearly have to select this cell, but I can't because there's no space here. If it would be like this, then there's not a problem. Yeah, I mean there's different ways of going around with this issue also. So for example, you could force it to output it in block format, and I think then it's a lot more clear how to do it. But I also think it could be of interest to just switch to the way of doing things with the MPCForces file, because with the MPCForces file, I had something like you have an X amount of characters, and then you just separate the strings by those blocks. And if those blocks do not change, I think then this would work. But on the other hand, what could also be a problem is that if the element numbers or the node numbers here are getting too big. So, for example, you would have like 3 decimal places left here. Three, yeah, you know what I mean. So there's nothing more than a billion elements or nodes that you could have. But what if you have a model with higher node IDs? What is this then doing? Does it increase the size? Does it use then 2 cells for 1 ID? I'm not sure how this is doing, how this is done then. So this is still a mystery for me. We could find something out like this if we just renumber the elements. So let's save that for short, and then let's do. There should be a renumber. Renumber offset elements. The problem is, how can I set now the starting ID? Ah, here. So I can select all the elements, and then let's start with one with a big number. Okay, and now let's run that again. I think export is something which is sufficient. Let's see how this is behaving now. Oh, it just okay. It renamed the elements. Let's rename the nodes. Let's make it even more big. Okay. Am I blind? Export. Yeah, solver deck. Save invalid elements to user mark. No, not sure why. Oh. Oh. Okay. See that? Okay. You cannot do that. Interesting. I never thought that would be a problem. So not for hypermesh. If this is a problem, then what did I just screw up? Let's try draft something different. Let's export the solver deck. Um, can I select something more here? Yeah. Let's just do template long format. Or is it free? I think it was free format. Let's do it like this. And yeah, you see, if you have something like this, it's way easier to get the thing here. Maybe I have this switched. Because see, now if I go to my beloved RBE3 elements, it would make perfect sense how it's done here. So you see, it's comma separated, and so you can it doesn't matter how big the numbers are. If it's bigger, then it could be as big as one line, and you never have I think something like this large. So I think the comma separated or the free format would be a good thing to change it to this one. Yeah, yeah. So I think in order that I have this working properly, I think I have to change it to a free format. Because just think about how would we approach something like this? I mean, we could do something with the spaces and stuff that would also work. Let's think about quickly about the benefits of having it like this. I think there's tremendous benefits to efficiency if you can specify the block size. Um, because then I think you can also save it just in one array, and then having access with yeah, with constant time efficiency. And you're losing that when you're doing something like with the free format. Well, on the other hand, no. To be honest, no. Just the pre-processing head should be different. But my stomach feeling is that you have efficiency compromises when you switching from this block format to a comma separated format. Because I think what we cannot do is doing like I'm not sure, like a pointer import or pointer reading where you just jump to a predefined location and you know exactly what would be in there. Um, no, you know what I mean? I'm not sure. So there is this thing called so the big O notation of how efficient or how fast an algorithmic solution would be. And for example, I stumbled upon these things when I did my thesis and had to guess the neighbor elements. And if you have a perfect grid of hexaeder elements and you save that in an array form, to get the neighbors is of constant time efficiency. That means um, it doesn't depend on the number of elements you have, so it doesn't make your code slower. Whereas if you have not this array-like structure where you can just move in one direction to just get the neighbor, you have to search for it. And if you have to search for it, then it's getting interesting. So the dumbest approach to do this is to do for loops. For every element, for every node, if some elements share the same node, then those are neighbors. And then you're getting back to the thing. So this is an n times n approach or so. It's not good. A better solution would be to have something like a tree size structure or something which reads in the elements. I think also the coordinates of the elements. and then builds a n-dimensional tree structure. And searching that tree structure is a lot faster to getting the neighbor elements. But this still also depends on the number of elements. So if you have more elements, you would have a lot longer, more computation to be done to get the same task, to get the neighbors of one element. And so here, if you just think about it, if the file is structured like this, and you have, for example, your section starting, and then you can go down and this amount of to the right, and you get the first idea of the element. And if you have comma separation, you would have to parse it, because this starting point is now not fixed anymore. So just imagine that the starting point of this cell would be where the blue begins here. You can guess that if it's a block size, and guess that prior to reading the file. The downside to this is that you have problems with large IDs, as we just saw. With this format, the comma is getting the point where the next cell begins, but it's not fixed anymore. So you cannot know prior to looking at the file, cannot know prior to it where this location is. So the cell location is unknown, and then that's exactly like the problem with searching for neighbor elements. If you have this array-like structure, you can just walk in any direction and get the neighbor elements with constant time scaling. But if you don't know that, you have to search for the place where the comma is here. You have to search for the common node between two elements, right? So this is the drawback here. And I have to think now, should I keep with the block format and just accept the limitations which also HyperMesh has, as we saw? So for example, if we just exported that with not the free format, right? So let's just make that one more time. Export solver deck, and again here, and let's do that block and also broken standard. No. Let's also try the other thing. Let's try the block long. I'm not sure if that's broken or not, but let's just try the long format as well. And look at the difference. So block broken was broken because the element ID is too big to be displayed here. So it's just stars. And the long format now, I think that has just a lot bigger cell sizes. Same problem, but I think just bigger sizes. Alright. So here with our IDs it worked, because now I think the long format has at least double of the sizes. So we could also think about staying with the block format right now, and yeah, just making our way through there with the block format. Yeah, I'm not sure about this. I mean, the easiest solution would be to switch to the free comma separated version, because there I don't think I have any problems in the future. I can definitely find the cells and stuff like that. But on the other hand, I would like to make it as default compatible as possible, and that would be the block format. So you don't have to, yeah, you don't have to go for the free format. And yeah, because later on, if you just think about a user having to adapt a solution, and he oversees that you have to use the free format, it will get frustrating pretty quickly. So that's not so great. And also with the, I think with the long format, I think I could detect very easily if it's a long or a short format with the block size, by just counting the number of cells and the number of spaces. So you could detect whether it's long or a short format and then adapt the block size, I think. Yeah, I'm not sure, but my gut's telling me to stay with the block size. Okay, block size it is. For now, let's go back to the RBE3 solution where we did not do the element renumbering, and let's try to import not the big numbers but this one. So this is what we're currently looking at. If we have to make that compatible with the block size, let's first look at how it's currently done with the rigid. So I think this should be in the model reader. Get rigid elements. So here's the RB2, and yeah, as I suspected, we had something like a line replace all spaces with this with the separation sign, and then split it by separation sign. Yeah, that's not there anymore. So let's just change it first to be able to use the block format without using something like this. Yeah. So let's just give it a sample line. And for that, I would need run 1, I think, for example. So this would be the sample line. So I can also search for RBE2 here, because I think that's a lot easier to digest. So you have the element ID, then you have the, I think the node, right? Then CM. Where's the DOF? Ah, CM is the DOF. Yeah. So here's it's more straightforward. Element ID, then you have the grid point where you have the 6 independent degrees of freedom for the element assigned. So grid point, then DOF, and then you have all of the nodes, and then alpha. What the hell is alpha? Thermal expansion coefficient. Aha, all right. Okay. So this is that. Okay. Now let's think about this. So we have a keyboard. Is it maybe 8? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 6, 8. 6, 7, 8. Yeah, I hope it is. So let's see, can I get that? How many selected? 72. Yeah, that sounds like 8 pretty much. That sounds like 8 pretty much. That sounds like 8 pretty much. So we could read that in as dividing the string divided by 8 characters, right? And then ignoring all the pluses because plus is not really helpful here. Yeah. The thermal expansion coefficient. Never thought that this would be the thing here. Yeah, pretty interesting. All right, so let's divide this. Always switching out of VS Code. So divide the line into parts of 8 chars. No, that's not what we want. I think this should be fine. Yeah, we have another variable, j. Yeah. So line content 1 would be the element ID. Is that correct? Yeah. We have the keyword, then this. Mm-hmm. Can I just overwrite the line content? I think so, yeah. So, from my understanding, this should work. Let's just make it like this. What? Ah, this is not this one. I'm just changing that to block size to have a variable here to be able to change it later pretty easily to have a long format. So where is this being used? So this is a public method. I also have to do a little bit more of the public and private methods here, so I'm not sure about the get nodes. Is that even used? Let's make that private all. Build node to property. Yeah, to be honest, I'm not so sure. Yeah, whatever. We leave it like this. Just focus on the issue we have at hand. So get rigid elements would be coming I think here. No. Ah, I'm not here. Here. Yes, here. Let's just do that here for now. Hmm. Yeah. Would rather have that here. Get MPC forces, that's on the top level, and the get MPC forces is here. And we can have that as an input parameter. Block size equals 8. So this is easy then. And I can already hear the linter. Hey, Vajish. Yeah, welcome to the stream. I can already hear the linter complaining about this because I'm redefining variables. So block size here, then it gets here, then block size here is used. I hope this is working. Block size, but yeah. Then we can leave that. And then it's used down here. Yeah. Let's see if it runs. And also we have to do linting for that one. Pretty sure. Does it run? Ah. We have used RE. Maybe we have to change that one here as well. It makes sense, to be honest, to also change it there. Just think about how we would import a node here. So this is the normal format, right? So this is, Yeah, exactly. Here you have the problem as well. See that? I hate how it's done there, but yeah. But this is just it's normal practice, so it's not anybody's fault. But so I think this also screams for 8-sized. 48. Yeah, you can also use the block size. You have grid, then the node ID, then you have 3 coordinates, and this is the first coordinate, and you have no guessing on where it would start. So to be honest, this is screwed. So let's not use the RE right now here. Um, let's do something different. No, not that one. So let's also use the block size here. Exactly. So this is line code, blah, 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 plus block size. Yeah, that makes sense. Now we have the node ID here, and then we can have it there. So it's not used anywhere, so that's not a problem. Is RE used here anymore? Here. Is this for... Oh, this is for elements, right? Now it's getting tricky. Because... Because I'm not sure if that's all the same. For sure it's not. But if you just check the C trier, so for sure this is also block size. Should also be dividable. Yeah. Yeah. Come on, we will just keep that and push that through now. And use a different thing. So build node to property should have a block size. And then the line content is something like this. So this should be correct as well. Yeah. And now we don't have anything more with RE. Yeah, and now we have a problem because we did not assign it here. Yeah, alright, that's not a problem. Yes, it worked. Now let's check for sure the output if this did not work. Ah, that was too early. It was too early. So it just did not work. Somewhere we did a problem here. And I think a problem is it's not child, hello, welcome. I think the problem here is in the column identifiers. I think those change. Those change. So my gut feeling is telling me it should be this one. Let's just see. So line content splits it with block size, and it says now the property ID should be the third element, because 0, 1, 2. And 0, 1, 2 would be 0, 1, 2. Yeah, this is correct. So should not be that of a problem. Okay, we have to dig deeper here. So we have zero results. Let's just make something like that. Let's print the rigid elements and see if it's empty or so. No, it's not that. It's somehow that it's not found in the MPC file. So the MPC reader has the problem. Here. No. Not found in MPCForces file. So let's think about what did we change. We changed the get nodes. Yeah, in this case, let's just make sure that this is working. Model readers.py, and then the get nodes we did not do really. So this should not be a problem. Read lines is unaffected. The build, this one should be it. Now, let's just print here the property ID. So those should be 1s and 2s. So this is correct. So I would say this block should not be the problem. Then the get rigid elements. Something like this. Let's see if this is a problem. Ah, okay. No. Okay, we have something here. We should not have done that. The poor computer. So I printed it as many times as I have lines here, so that's not good. But in the end, I have an MPC, and then it complains about not being found in the MPCForces file. It's a bit too much, right? But we have 3 separated SPC forces here, so this should not be the problem. So this should not be the problem. So what did we change to? What did we change? That's the top level. So I think this one is broken, right? To get MPCForces. But I cannot see currently where. So if I just inspect that. So we go here now with a block size. Maybe we have just to. Does this work even? I think not, right? That's also what I hate about if you have this task file, it really makes it hard to debug. I have to think about how to fix this in the future, but I cannot do that right now because that will lead us nowhere. So we have to debug with print statements and stuff like that. So build node to property should work, right? Because the property it did get. So I think this is not a problem. Get rigid elements also is not a problem. Yeah, happy debugging, eh? Let's see where this is. So this is too many nodes here, right? Is it? To be honest, no, not too many. I think this is even not a problem. So the problem is that we have in output text, we have sum of forces which is 0 everywhere. So the problem arises from the MPCForces summing, or there's it should be evident that this is all zeros. Now, here I always used this thing. I did not change it, right? MPCForces reader, I did not change at all. No. So the only thing it could be is this node to property file. Because if it's then summing up everything, then I think 0 would be Snowchild. Thank you for the $20. Thank you very much. Yeah, cannot understand that. Me doing here the boring debugging stuff. is so great here, but yeah. Thanks again. Um, yeah. So where is it that we have a problem? I think I'm like blind now. But Sainaidu, hi, welcome to the stream. Um, yeah. So my gut feeling is still it's somewhere here. So we have an element ID, which is line content 1. Let's just maybe print a line content here, that we see what we're dealing with. Hmm. So this is it, right? Oh, I see where the problem is. I think we did an override of we're now okay. Okay, which file are we using right now? We're using the file rigid2. And this file rigid2, but I did not think I changed that. Did I? No, I did not. So why? Okay, but I think I now know what the problem is. So we have now this RBE2 element, which is here. And somehow I think I still did a replacement with commas. What the hell? Where is this commas? Ah no, sorry. No. This is just the structure. Okay. But I still think this is a problem. I still think this is a problem. Let's see. So the model reader. The element ID is now the first, so 0 first, this one, which is correct. The DOFs would be the third one, this is also correct, and then we have this one. But I think we have to strip that. And you also see here again that there's a problem when you're not doing really typing stuff. So type checks. To be honest, this is really a bit of frustrating because the element ID, the DOF, and the nodes, if I would have done that correctly, I would have some type checks here because I expect that to be numbers, and I think that's because it's then used later on as a key, and if it's a string with spaces in it, that's not a good thing. So let's just make sure those are integers. The DOF should be an integer as well, and the nodes, haha. Because here there's a problem. So node strip for node in line content. Because here it's an array. And I want to make sure that it is an integer array. So int node strip. I think this will now not run because I messed something up. Yeah, I think you cannot do that with the cannot do that. Does it work now? Key error 401. But it's better now. So now we have a key error. Yeah, So this is a lot better now, I think. But it now has a problem with the property ID. This property ID is here, node to property. And this node property, sort nodes by property. Where is this? This is being used somewhere here. And then you have the reader, node to property. And reader, node to property, I cannot jump there, but the reader should be the FAM file reader. So the node to property, build node to property. I think we still have the problem here. So the property ID should be also something like a number. So property is a number, and node.strip. By the way, if you have any questions about something unrelated to the code here, it's not a problem. Just ask them, and I will be happy to reply. Node strip for node in the line content. So if we have something like this, we're getting away of all the spaces, right? I'm still not sure how to make an integer array of it. Well, I don't know why this did not work. Let's see if this is working. I think you cannot use the int. But if that's working, then let's make it like this. Maybe then also we could maybe get away with a single line. It's exactly my solution. All right, I thought there would be maybe a better one, but yeah. Let's just do it like this. I think it's converted to an int. Hopefully. Or maybe just, yeah, it's parsed as an int. Yeah. All right, so now let's check the output file. I hope now we have some better values here. Yeah, okay, now we're back to business. Okay. Okay, now we have converted it to the RBE, to the block file. I think this is good to... What? Yeah, then I don't want this to be this output file. Can we remove this? I know there's a command to remove it. But if I delete it, can I now commit the delete? Because yeah, I know. Yeah, I will just try to commit it anyway. So change the reader to block size format input. Sync it. Okay. Now, what we have now here is it's working for RBE2, but not for RBE3. But that's the main issue. But I think now we can also get the RBE3 implementation a little bit easier. Because we now have the foundation of reading it block by block. And that makes it easier. Or maybe just possible at all. The thing what still is on my mind with where I'm not sure if it's working or out of the box working is that you have here different sections and I cannot really tell how to differentiate between them. So there is something like a G11 GIJ grid point host components CI have weighting factor VTI in averaging equations. But why is there a J index? So you have here a C1 and then there's a C2 and then etc etc and then there's a C3 and then there's maybe a C4 5. But I cannot make it, I cannot get it or grasp it directly why there are 4 different components and how to differentiate between them. So to just look at the file here now. Let's maybe also copy that. That would be run1 RBE. So I copy the FEM, SPC, and MPC forces to the input. So we can also use them. So let's close all those. Well, let's maybe close all of them. Now, if I look now at the section, so I see definitely there's a 1.0. This would be a weight. Then there you have 1, 2, 3, which are DOFs. And then you have nodes. And I'm not sure why this is like that. That you don't have separation between multiple. So yeah, just think about this one. You have the ID, then it's blank. Then you have the, what was that? The reference grid. Yeah, element ID, then the reference grid ID, then you have DOFs, then you have a weight, then you have another set of DOFs. Okay. Then you have some nodes, then you have a weight. Then you have maybe a DOF again, I think. Because you have a weight, then you have a DOF again. Then you have nodes again, then you have a weight, then you have a DOF again, then you have weights again. So if it's not uniformly, you would have maybe 4 different kind of weights. So I would have to think about this, how to do it. Yeah, let's see. I have an idea. My idea would be to start at the defined point where the nodes begin. Then loop through all the nodes whenever I have something like a dot in it, because that's a weight. Even if you have a weight of 1.0, that would be a 1.0. You can also see that here. So 1.0, this is a weight. Then I will skip this cell and also the next one, because that's stuff and not a node ID. And then I just go on my way until the end of time, until the end of the input. There's no alpha here. Interesting, right? Or is it? Blank, 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 but I don't see an alpha here. Not sure if that's a bug or if that's really the case. So maybe it seems like it's an option here. So you have blank, etc. blank, then alpha and alpha, but alpha is not there. Right? I don't see an alpha here. Is there? No. Right? So if there's an alpha, we could simply also ignore this cell and the next one. All right. That's a bit of a thing to do. Okay, so let's start implementing this. Therefore, I go into the, I think the model reader, right? Here, that's the RBE2. Maybe I also have to put that into separate methods. Yeah. Yeah, I think I have to. I have to. Let's just think about this thing. I can do it as a private method. I would do something like cut all this into a separate method. I think right now we don't have something to get back. Something like this, but so we read in RB2, so this would be this method. I'm not sure why this is a bit strange here. Something like this. Yeah, we have to give something more than the block size, right? Oh, that's not so easy to get that into our own method. You see that the problem is that I just have to give I don't have to give only the line, but also yeah, it's not that great. Okay, let's try it again. Let's try it. If it's not working, um then that's also okay. So we have line, which is a string, then we have line number, which is an int. And this line number yeah, the linter will complain if I just use I. So we have to do this. We have a line number, which is a different named variable. So line number here, then we have line number +1. This is line 2. Whatever, j, that doesn't it's not that. Line number. Wait a second. What was there? It was just I. Don't get me confused here, Copilot. And then maybe we also have to return line number. Because if it's then doing all those kind of things here, it just has to return the I too. Because the next line should be then farther down the road. Yeah, I'm not too happy with it, to be honest. That could be a bug in here. Doesn't seem like it. Seems like it worked. Yeah, but maybe I will have to refactor that in a future update. All right, that's that. So we have now the structure of it. It returns now not none, but an integer. We have to make a little documentation of it. Reads in an RBE2 element with block data. Yeah. Okay. Now let's do the same thing for the RBE3 element. Def read RBE3 should be the same thing. Now let's see what it comes up with. Yes, we don't have an RBE3 right now. We should maybe. For right now, I think it's the sum forces by property should definitely be something of the MPC. Because then I just don't need to implement it again for the RBE3. So what is different for RB2 and RB3? I mean, RB2 and RB3 have different kind of properties, but in case of the things what I do right here, for this thing, I think it doesn't matter. But I will implement it this way anyway, because maybe I want to extend the functionality later on, and then I need maybe different kind of properties. That's why I do it like this. So class RBE3 is also MPC, and then let's define a, what should we do? Is the nodes by property really a thing? It doesn't make any sense, to be honest. It doesn't make any sense. Because also, if you think about this, this is also a MPC method. I think we will drop we will drop the differentiation between RB2 and RB3 completely. And just use MPC. Now the linter will not be happy, so because that's an MPC now, there is no RB2 anymore. Yeah, I think that's easier, right? So the read RBE3 now. That should be then taken differently than before. So the element ID I think is still the 1. Then the DOFs I think is now different. So let me see that. First change the song. Okay. Now, in order to test this, let's just switch the MPC tools to be using the RBE3 file. Let's just, no, that's all good. So we need not the rigid, but RBE3, I think. Right? Yeah, it doesn't have anything, right? So simple RBE3, so that makes sense. Now, let's now see. So there's nothing in here. Yeah, that makes sense. Now, let's see the data we're looking at. So rbe3.fem file, this file exactly. So first one would be the element. 2, 3 would be the reference node. So 4 would be the DOFs. And then I think it's 6 going on. Let's see again. So 0, 1, 2, 3, 4, 5, 6, no, 7. 7. Now the more interesting thing is if it's now having more nodes here. How to do that? So there's two ways of doing that. One way is to removing it after you add it all, or the other one is to check if you should add it and then prevent it from adding if it's not what you want. So let's make it preventing it from from adding it to it. So let's call that, what is this? Data. Let's just call it data. So this is data entity.strip for entity. No, I think this is not, I cannot use list comprehension here. I cannot use list comprehension for entity, or entries, even better. If, that's also not correct. Sorry. No. I'm getting ahead of myself. For J, So if j is continuing, that's a plus sign. Then if line content j is... No, it's not equal to an empty string, but is it if a dot in? Yeah, if it's a float. Then this is a weight, and I can j plus equals 1. So this is getting ahead of one thing, and then continuing would get another thing ahead of it, right? So, and then I can... Else, that would be... no. So, nodes is a value here, right? That's okay, I think. I'm just thinking about if it's also in the first line occurring. There you have something which... So, yeah, let me back off a bit. So the problem is those things. Yeah, and you see here that you have the weight and the dov, and then you have the first node. If this is the first node, and then there's a float here, because there's just one node assigned to it. So this would be this float, so I would have to skip it too. But this can only be the case if it's just one node. So it's pretty a corner case, I would say. But if that's the case, would I catch that? I think not. Right now, not. I maybe catch that if I just remove everything which has a dot in it. So removing the weights. Yeah, it's not so beautiful, to be honest. I had to do something like this also for the first line. So let's think about the second line, yeah? Let's think about this line. So for every here, the first thing I will skip. So this is the first continue. This is this one. If j is 0, then continue. Then first one has no dot, will be added. 4.7 has a dot, will not be added, and I jump over this one too. Because this one is a dov. So you have to wait. Sorry, you have to wait, which is this. Then you have the dov, and then you have nodes again. So this is it. And if none of this is the case, so we have a node, then you could say nodes append line content strip. Right? Let's test it. Seems awkward. This is the read RBE3. Yeah, okay, it's not it's not being used. Okay. So we have now this thing. And also the new line character, right? The new line character has to be skipped as well. Did I skip that here? No. But I should. To be honest, I should. Does that make sense? To just strip everything. Is this then also removing the new line character? No, it doesn't. No, it does not. By the way, where I'm printing that. Sorry. This should be printed then here. Otherwise, it will not have the right data. But if this is stripping the new line character, it's just first step of splitting it. Yeah, I'm fooling around here, to be honest. So we could remove the empty spaces, or we could also just, because there's a new line character. Is there not something like remove the new line character? I would guess so, that this would work. Yes, this works. Let's do that. I think this is proper practice. And let's also try, let's try to duplicate this, and let's see if it still works. If there's no new line character. Aha, okay, yeah. So this is a pitfall. So this is a pitfall. If I do it like this. But why? I cannot get out of here. Okay. If it's like this, it should work. Yes, this works. Does it still have something good in output? I'm not sure if I even checked that. Oh, that's interesting. Oh, we have to do debug here. We have to do debugging here, definitely. Not sure if this does make any sense. But okay, so this is working, right? So I think I will just yank this file and out this line and apply it also for the RBE2. Is it the only thing where I do something like this? Ah man, this delete yanking, that's so unnecessary. Hmm. Okay. Okay, that makes sense now. All right, now we get some results. Now let's check if that makes any sense. So the RBE3 does not have any reaction force, really. So basically it's all 0 here. And that brings me to maybe also researching a little bit more the way of this, how it's working, right? Because the RBE3 is the RBE3 other than the RBE2 lets the nodes, the slave nodes, move in relationship to each other. Now let's maybe just look at what the results would be. If this model is just flying away, then we have our answer. Could also be the case. But still, I think this is valid to use something like this. Maybe we have to make little adjustments of how we would go about it. Because basically it just seems to be affecting if the master node has something of a force applied to it. So it could well be that it is now here flying away. Yeah. It's flying away. Yeah, that makes perfect sense. The RB3 to use in this case of a scenario is quite stupid. Without having some constraints on here. If I would constrain this node, is that even possible? I think constraining the master node on RBE3 is a bad idea, if I'm correct. But I could apply a force there. So maybe that's not a best test model, but it gets us the data what we wanted, I think. Let's see. Because we can check that very easily. and we have not checked it before. Yeah, and it seems that it's not working. Because what about those columns? Those columns are not in the output. So the moments, not sure about it. But let's just see if the first columns work. Ba -ba -ba -bum. So we go to the MPCForces file. I will just copy all of that. And copy that into a spreadsheet. And now doing the sum of it. So 2 to the power of -8. So something is not adding up. Because I think the numbers here are quite higher. Ah, sorry. Yeah. It's for sure separated by property. So we should do something like this. Yeah, that makes sense here now, right? Yeah. Okay, so this is correct, but I'm not sure what about moment columns. I think there's a bug. Because yeah, I see why. I see why. Because the reference node is not in the node IDs. I'm not sure if it should be there or if it should be separately. I will keep it separately for now, but there could be a thing here, so I will create another short issue here. Think about the RBE master node not being summed up. And no message. Is this a bug? Okay, then I have noted it there. Alright, so this is it. So I think we could properly say that the that the RB3 constraint now is also included. So I would add the changes I made here to the commit. That would be the basic implementation. Commit. And then we can see the wonders of the pull request, because I did not create a pull request until now. So if I see on pull request, I can compare and pull request. So closes issue 2. So this is a basic implementation of also implementing RB3 functionality. So I signed it myself. Always good to review your own code. Then this would be an enhancement. Alright, there's no milestones and stuff like that for now. Because what I like here is you have multiple commits here, right? But you can also see in the files changed a pretty good overview of what changed, right? So let's just see what the changes are and then comment on them. Yeah, so that's what we did today, or today morning. I have to see if I have the time and the energy today afternoon or so do another round of getting this thing a bit further. Maybe what I think would be the best new thing or new stuff right now is to extend the functionality to 3D elements, because right now there's just only 2D elements supported. So we would have to add a lot of elements um, element keywords to it. So the model reader, I think there's this. Yeah, maybe we can also tag the property thing here. Yeah. Oh man, there's so much to do. So just because I did not tell you that, or did not mention it already, there is in the FEM file, there's something like a comment before every element selection. Or element section. So here's an element section of C trie elements, and you have an element component ID here. So you have trias there, you have trias here, and I think the 1 or the 2, this is the component ID, and I think this is the property ID, and the 4, maybe the material ID. I'm not sure, but seems to me to be a good information here to just take the component ID from here, because that makes us able to get away from the necessity to have individual properties linked to the different components, because that was a bollock. And if you just think about reading the elements in, you could just check for the component ID in the section above and then assign it right there. And that strips away the property thing. So we don't have to do TCL coding to duplicate all the properties and assign it to the different components, because that would be necessary for the script to work for for different components, right? So I think that could be an issue we could solve too. But I think the main thing to do now as a next step is to enhance this thing to be workable with 3D files or 3D elements. Because, yeah, not everything is 2D. And 3D should be rather straightforward. So I think maybe I will also do that off stream and just implement something here. Yeah, then let's see. I mean, it's a pretty interesting project right now already. And let's see where this takes us. All right, if you have any questions, comments, you know what to do. Other than that, thank you for being here. Thank you for contributing. And yeah, Snowchild, if you're still around, thanks for the donation. It's really appreciated. And yeah, have a good one. Take care, guys.